This movie is for Learning Target 4, Medians and Altitudes. This is Learning Target 4 in Unit 5. You'll need your purple sheets out, pencil and paper. Let's get started. We're going to skip this slide. We're going to go right into this one. You're going to have to add this onto your purple sheet. A median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So extending from this vertex to the midpoint of the opposite side, we call this a median. A triangle's three medians are always concurrent. Concurrent meaning they do intersect at a point. So pause the movie, add this to your purple sheet, press play when you're finished. We have the concurrency of median theorem. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So you can see here, if we look at DC, it's going to be 2/3 the length of DJ. So from D, the vertex, to the concurrency, the point of concurrency, the medians, C, that's going to be 2/3 of the entire distance, DJ. Just like E to C is 2/3 from E to G. And F to C is 2/3 from F to H. Pause the movie, add this to your purple sheets, press play when you're finished. The centroid of a triangle is the point of concurrency of the medians. So that point that we were talking about, where all the medians intersect, that is called the centroid. This point is also called the center of gravity of a triangle because it's the point where a triangular shape will balance. So you're actually finding the centroid if you would want to balance a shape like a triangle. The centroid is always inside the triangle. Should be logical. If you're going to try to balance a triangle, it would not make sense to have the point where it balances be outside the triangle. Add that to your purple sheet that it's called the centroid of a triangle. The point of concurrency of the medians. Let's find the length of a median. In this diagram, XA is 8. X to A being the centroid, is 8. What is the length of X to B? Well, we know that it's the centroid, A, because it's the point of concurrency or where the medians intersect. And so we know that XA is 2/3 the distance from X to B. So XA is 2/3 XB. I'm going to plug in 8 for XA, and I get that 8 is 2/3 XB. Now if I multiply both sides by the reciprocal, 3/2, I've got 8 times 3/2, and 2/3 times 3/2 gives me 1. So that allows me to get 8 times 3 divided by 2 is 12. So XB is a length of 12. Pause this movie, try number 1A and 1B on your own, and press play when you are finished. All right, in 1A, in this diagram, we have ZA is a length of 9. What is the length of ZC? Well, because A is the point of concurrency where the medians intersect, we call A the centroid, and we know that ZA is 2/3 the whole distance. So ZA is 2/3 the length of ZC. So 9 is 2/3 ZC. I'm going to multiply both sides by the reciprocal, 3/2. I get 27/2, which ends up being 13.5. So for 1A, it's 13.5. And for 1B, what is the ratio of ZA to AC? Well, ZA is 2/3 of the whole distance, so AC must be 1/3. So it's really 2 to 1. And you can see here, we end up getting 2 to 1 right here. 2 to 1. An altitude of a triangle is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. An altitude of a triangle can be inside or outside the triangle, or it can be on the side of a triangle. I always think of an altitude if we were to have, let's say this is a mountain. Yep, that's a mountain. Here's the earth. An altitude, let's say you're up here. There you are. Your altitude would be the straight down distance, the perpendicular. If you were to cut through that mountain, that's an altitude. So I constantly think of climbing a mountain and being at a specific altitude on the earth, meaning your height away from the base of the earth. So you can see here, this is an altitude. Did we add that? Yep, this should be added to your purple sheets. So you can pause the movie, add that altitude, then press play when you're finished. Okay, identifying medians and altitudes. Let's look at this triangle, PQS. Is PR a median, an altitude, or neither? Explain. Well, we see PR extends from the vertex P, and it's a perpendicular to the opposite side. So because of that, we say it's an altitude. It's just like giving us the altitude or the height of a mountain. For PQS, is QT a median, altitude, or neither? Well, QT extends from the vertex to the midpoint of the opposite side, and we call that a median. So we say that QT is a median of the triangle. For triangle ABC, is each segment a median, altitude, or neither? Pause the movie, answer A, B, and C, and then press play when you're finished. All right, we're looking at AD. It extends from a vertex to the midpoint of the opposite side, and that we call a median. Looking at EG, it extends from the midpoint of this side to the midpoint of that side, we think, but we don't know. There's no indication, so we say neither. So E is a midpoint of the one side, but G we don't know, so it's neither. And then CF extends from a vertex perpendicular to the opposite side, so we call that the altitude. Altitude does not always go up and down. It can definitely go left to right, on a catty corner, but it does extend from a vertex perpendicular to the opposite side. Pause this movie, add concurrency of altitudes theorem to your purple sheet, and press play when you're finished. The lines that contain the altitudes of a triangle are concurrent, meaning they intersect. The orthocenter. The lines that contain the altitudes of a triangle are concurrent at the orthocenter. We call that point the orthocenter. The orthocenter of a triangle can be inside, on, or outside the triangle, and here are the three cases: inside, on the triangle, and outside the triangle. Pause this movie, add orthocenter to your purple sheet, and press play when you're finished. Finding the orthocenter on a coordinate plane. Let's say we start off with triangle ABC. A is at 1, 3, B is at 2, 7, C is at 6, 3. What are the coordinates of the orthocenter? Step 1, find the equation of a line containing the altitude to AC. So it needs to extend from point B and be perpendicular to AC. AC is a horizontal line, so I know it's a vertical line that goes through point B, and that's what gives me this orange line. That equation is x equals 2. Then I want to find a line that's perpendicular to BC that goes through point A, the blue line. To do that, I got to find the slope of BC. The slope of the line containing BC is -1. That tells me a line perpendicular to BC must be a product that gives me -1, so the slope must be 1. So I go through point A with a slope of 1, that gives me this blue line. and I draw the blue line. Because I only need 2 altitudes to get the orthocenter, I can stop there and see that right here where they intersect is the orthocenter. So the line passes through. Oh, that was part of step 2. So these 2 equations meet up at this ordered pair, which is at 2, 4. So the coordinates of the orthocenter are at 2, 4. Pause this movie, try this one on your own, press play when you are finished. Okay, so you've got points D is at 1, 2. You got E at 1, 6. 4, 2. And then we've got this triangle. Now what's nice about this triangle is that it's a right triangle and I've got a horizontal and vertical line. So if I want to go through this perpendicular to this side and go through the opposite point, that's going to give me this line right here. And if I want to be perpendicular to this vertical line and go through this point, that's going to be this line right here. So my orthocenter is going to be this point right here at 1, 2. Right triangles are the easiest triangles to find the orthocenter because it's always where that right angle is located. As you can tell in our previous problem, that wasn't the case here. This is in summary. These are all the things you'll need to know. Perpendicular bisectors, where they intersect, is called the circumcenter. Our angle bisectors, where they intersect, is called the incenter. Our medians, where they intersect, is called a centroid. And where the altitudes intersect is called the orthocenter. This is a page that I would copy down because it's visual and it's got all the terms that you need to know in it. I would definitely add that to my notes. That's all. You can pause this movie now or stop this movie. Pause it if you want to add this to your notes. Then I would like you to start working on your homework.